So my name is Jorge Sanchez. I am the Director of Product Strategy at Appian. And with me today is Jason Sims from psHealth. And today we're going to be talking about creating the next generation of smart apps with artificial intelligence, but more specifically, machine learning. So I am not going to be spending too much time talking about what is machine learning and things like that. I figure most of us probably already know what it is, at least at a high level. The one thing I will say, though, is typically when we think about machine learning, we really put ourselves into one of two categories. I'm either a user of machine learning, meaning I have a model, it's already been created, it's kind of a black box, and I use it to make predictions, or I'm a designer of machine learning models. That's where you get into the mathematical concepts and the data science and all the different algorithms that you can use depending on what type of machine learning model you're using, blah, 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 blah. And we have to ask ourselves, what kind of machine learning users are we? And I would say that the vast majority of all of us are kind of in the latter, right? We're all happy to be blissfully unaware of how all of these complexity happens, because at the end of the day, you don't care how all of that happened, you just care about the end result. What is the prediction, right? And that's a lot of what is happening today, thankfully, because before, in order to get started, and I know this because I actually got started with the former, I actually got started reading about it, learning about, or relearning about combinatorial mathematics and advanced statistics and all of this stuff that you need to learn to start thinking about how you create the model and how you prepare the data and all of that. But most of the time, people are just going to see, you're going to click a button and they see the result. It's like when you're cooking for Christmas dinner or when you're cooking for a big family event. You spend all day cooking for it and the whole thing's over in 20 minutes, right? It's similar to that. Now, for those of you that were here during the keynote presentation, you heard Matt, you heard Malcolm, you heard me talk a little bit about what's so exciting about machine learning and artificial intelligence. And I wasn't kidding when I was telling that story that I used to devour books about AI, and when I would see a movie that talked about robots and artificial intelligence, I'd be the kid sitting on the edge of the seat thinking about what it could be. But what's really exciting, as I mentioned, is that this is the year that it's actually happening. It's the year that it's going to begin being used by all of the enterprise and organizations out there. And if I were to make a prediction, I would say that people are going to start fiddling with it this year. They're going to start having a couple of ideas of what they can do, what they can use it for. But I think that everybody's going to start to demand it in any platform that they use by 2020, maybe earlier. We'll see. You might be able to quote me on that. But it's definitely something that is interesting. So if you want to see, or you want to talk about a little bit of what are the top 10 most talked about use cases today, companies are using AI and machine learning today for all of these things and many more, but primarily these are the top 10. So when you're talking about data security, when you're talking about how do you react quickly, like when you're having an attack on your data center, when you're having a specific coordinated DDoS attack and things like that, how can you use machine learning to identify the patterns of where the IP addresses are coming from and blah, blah, blah. A human couldn't do that fast enough, especially with a distributed attack. Personal security. We all heard the news back in 2014 and 2015 about Home Depot and Target and all of that stuff, and like even the government, right? They lost so much data for personal security, and now we're thinking of how we can use machine learning models to prevent and protect more of our personal security. Finance trading, so I've seen products come up recently like Betterment and the like, where all the investments are done by computer algorithms and machine learning models. It's incredible. And I actually personally have a friend that uses it, and the performance is not, it's pretty interesting, better than what I've done. Healthcare, also another interesting use case. Marketing personalization, fraud detection, recommendations. Natural language processing is another very important one, and I think it's very related to machine learning because oftentimes we're working with unstructured data. You have a letter, but it's hard to just give a machine learning model just letters and tell it, go learn, go forth and learn. But with natural language processing can help you take that unstructured data and with a combination of other technologies like OCR and syntax analysis and things like that, convert it into structured data that you can then use to further analyze the data with machine learning. And of course, we've all heard about smart cars. I don't know about you, but I'm excited about that one. I mean, I do look at people driving their Teslas in autopilot with just a little bit of envy. But we're going to see more and more of that. By 2020, they might be fully automated. So these are 10 use cases that you can kind of keep an eye out on all the different things that you can do. Now, when we talk about Appian and machine learning, and when I was thinking about where is Appian's role in all of this, it's an interesting question, because when you think about it, Appian is a low-code application platform. But although we have frameworks and we have applications that we sell, we don't really give a specific pre-made solution, right? We rely on our professional services, on our partners to do all of that, and some of our frameworks, but we don't really do like there's kind of two categories, general AI and applied AI, and all of these are examples of applied AI. So machine learning with Appian, what we thought we would do is make it easy, make it available, deliver on the promise of democratizing AI. And as we typically do, the first and most important thing that we have to make sure is happening is it has to be easy. So I placed a bet at the beginning that most of us are in the area of machine learning. We want to be able to use it. And if any of you go right now to some of those providers out there, and I'm talking Amazon AWS, Google, some machine learning, Microsoft Azure, they are developer friendly. They're not like business user friendly. You still need to know a little bit to configure it, to do all that stuff and integrate it and all that. But it's also not enough just to give you a connector. Because even after we figure out the connector aspects, you still have to know how to create a data model, and you still have to know how to do all of that stuff. So what we wanted to do is abstract all of that information out. So we want to provide something that is walk-up usable, that doesn't rely on your previous experience or knowledge on artificial intelligence in order for you to be able to start using it. Now, granted, any machine learning model, crap goes in, guess what comes out? Right? So you still have to make sure you feed it relevant information. But if you have it, just like you will learn in the use case with psHealth a little later, you will no longer need to manually create all of these rules and have people and subject matter experts that are looking at those hundreds of thousands of records to create prescriptive rules that can help you make recommendations and predictions. So we have an assisted wizard for quick and easy. We did it last year with quick apps. Now we're doing it with AI. Now, it still needs to be powerful, right? So it needs to leverage the whole power of the Appian architecture. So you can use your machine learning models with just one rule. One rule where you specify every machine learning model, as Matt mentioned, it becomes a record. And all you have to tell me is, what is that record reference? And what are the attributes that you're trying to predict? So if you're trying to predict information such as the churn propensity of a customer, you might pass in the customer ID, the customer geographical information, demographical information, the kind of products they have, blah, 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 and then you get out a propensity, a percentage, a yes or no. It depends on how you modeled it. And it supports many different prediction use cases. Now what's exciting is what I'm going to show you today is only a glimpse, right? This is evolving more and more and more every single day. And it's really exciting. And they do say that in order to democratize machine learning, we're going to do it in just 3 steps, right? So the first step, as I mentioned before, and for those of you that were in the keynote, it's going to be to upload your data. Once you upload your data, we're going to create that data model for you, and the only thing you really have to tell me is, what are you predicting? Out of all these columns in this data, what is it that you're predicting? What's important to you? And then you create the model, and you can make predictions anywhere. But they do say that a picture is worth 1,000 words. So with that, I'm going to actually switch over and give you a live demonstration right now of that. Before I actually go through this, I want to show the data that I'm going to be using to train this, just so that you have a little bit of background. This is actual data that was captured from a bank, and what they were doing is they had a marketing campaign where they hired people from a call center to call prospective customers. And in that call, they would make an offer of a specific banking service. Like, hello, I'm calling from so-and-so bank. I noticed that you're a customer with us. I would like to offer a certificate of deposit, blah, 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 whatever, right? So they were making these calls, and they would capture regular information like demographics, what's the age, the job, marital status, type of education, whether they have a housing loan, whether they've been contacted in the past, some generic information about the overall employment rates and things like that, and indices. And the last column, this Y column right here, captured whether or not they accepted or not accepted the offer, right? Simple data. I bet many companies and many banks have something similar to this, where you make a phone call, make an offer, or maybe send an email, and you have the success rate, right? And when you add some information like this, then it's very simple to do that. So let's create a model that can help us predict a customer's upsell propensity, right? And I capture just a model description, and I can say this model predicts how likely a customer is to be upsold. You can specify some additional metadata. Then you specify the training data. So this is a part where you actually upload your data file. You say, okay, these are the repositories available. Where do you want to save it? I want to save it here. And you click next. And this is where it starts doing things for you, right? The only thing that you're going to do is review the training data as an FYI. Appian automatically creates the data model for you. It looks at the data file, and it identifies, you know what, we have age, job, marital. This is the data type associated with the best guess that we had of what the data is. If you find something that may need to be updated, you can change it if you want to, but most of the time it's pretty good at depicting what it is. And the only required field here is, what is the target attribute name? What is it that I am actually trying to predict? You have advanced configuration options. I'm not going to show them right now. They are essentially, if you happen to be one of those people that have data science background and you want to control a little more of how the model is created, you can take a look at those options, but that's beyond the scope of this presentation right now. Most of the people, I would imagine, are just going to go straight to the confirm and build model. So this is actually not going to create a model and make it available immediately. Right now, as we speak, this is going through Amazon's AWS neural network, analyzing your data, finding different patterns, and doing all of that information, everything that it needs to in order to make sure that the model is readily available for you. But just like I said before, you'll have it available as a record, right? So here's the one I just created, predict customers' upsell propensity, all right? And when I click on it, you'll see details about this model as they are becoming available, right? You can see this one's still pending, right? And you have some additional information, the model that you use, you can update it, upload more data, and then make sure that you keep it up to date. But I'm gonna go to one that has already finished, so I don't have you here waiting on it. It's this one right here. And you can see that this one's completed and the real endpoint status is ready. This means that the rule that I was talking about earlier is ready to be used anywhere you want. So let me show you an example of what that could look like. So imagine I go to a banking customer's record, right? And I have some basic information about my customers here, but I have these two columns. These two are actually being populated from two different machine learning models. One that calculates the propensity of a customer to be upsold. Another one that calculates the propensity of a customer to default on their next payment. Two metrics, I believe, would be very important if you were in the financial industry and want to know what's happening with your customers. So let's take a look at what happens when I click on Angela Lewis, right? So I click on her, and I see some additional information. And because she can be upsold, I have a related action that says, what are the best offers available to her? Now, most of the time, I would not really design an application this way. I would make it completely automatic. I would make this business rule be in the process so it automatically knows which customers can be upsold and automatically sends the offers, right? But if I did that, I wouldn't have much to show you, would I? So I created it this way in order to be able to show you the type of data and details that you would see. So you can see here some information about the customer, what services they currently have, and what is the affinity for the products that haven't yet been offered to her. So this is running another machine learning model that finds that affinity. And then when you select, for example, the one that you would recommend, obviously the next question is going to be, okay, you're offering me a money market. Given my specific profile, what should I do? How should I invest my money? So you can see the orthogonal kind of relationship between all of the different machine learning models. And yes, most of the stuff I've shown you here can be prescriptive, not predictive. I can have subject matter experts go and use our decision designer, which is a fantastic tool, and create that for you. But if you have the right data, you can automate it, and you don't have to spend all this time doing it yourself. So let me get back to the presentation. And this would be a fantastic time to introduce you all to Jason Sims from psHealth. So I'll let him do his own introduction and details about what he does. But everybody, please, Jason Sims.
Thank you. All right. Good afternoon, everyone. So, yes, my name is Jason Sims. So I work as a product manager for a company called psHealth. I am an Australian, but I am based in Waterloo in London at the moment. So I've been in health technology now for around 7 years and a product manager for the last 3. I'm really passionate about innovation in health technology, and I'm really excited to be able to talk to you a little bit today about what we're doing at psHealth and also how Appian is really driving some of the work we're doing. So psHealth, it was founded around, I believe, 10 years ago now with the aim to help clients deliver more efficiently at a lower cost. So the company initially delivered custom case management solutions to UK private sector organisations. And look, Appian has really been a big driver for us, getting this work done since around 2010. So it was our successes in the private sector that led some opportunities for us to work with the United Kingdom's National Health Service, or NHS. And it's this work that I'm going to talk a little about today. And talk a little bit about the current state of the public health system, what referral management is, importantly, and how Appian's AI service is really helping us meet the challenge. So, the referral management challenge. So, traditionally, the health system is structured in a way that you'll go and see your general practitioner. He'll diagnose you with some condition, and then they can refer you to any secondary care or community care service that they want. Now, where they refer you is largely uncontrolled, in that you could go see 2 practitioners, and they could refer you to 2 different places, and you could have the exact same condition or the exact same problem. So the problem with this is that in the UK at the moment, we have some really high-cost secondary services, and that they've been established, and they're under massive budget pressures and demand pressures. And then on the other side of the coin, the government set up community services that have been designed to treat specific conditions. Now, these are being underutilised, and they're a lot cheaper. So there's something that needs to be done about this. So, and this happens for numerous reasons. So it can be around communication to do with new services being released. It's pretty poor. You can also have that there's the general practitioners can be hesitant as well to actually refer to a new service, which is completely understandable. So bear in mind, they only want their patients to go somewhere that they know that they're going to be treated. Sometimes if there's a new service, they don't want to use that. So referral management, what it is essentially it's reviewing all referrals that come out of primary care from general practitioners and trying to make sure that they are appropriate, that they're going to the most cost-effective secondary care or community care option, and that they also get the best health outcomes for patients. So I'm going to play a short video now. It's from Peter Devlin. He's a general practitioner. He's also a founder and a director of clinical leadership for an organisation called HERE in South England. He's one of our partners. He's just going to talk a little bit about what demand is. He's going to talk about the state of the NHS and what machine learning can do.
Has a very deep voice.
Yes.
I'm Peter Devlin. I'm a GP in Brighton and Hove, and I'm a co-founder and director of clinical leadership at HERE. What we're noticing at the moment is that the UK healthcare system is under greater pressure than at any stage that I can remember in my career in the NHS, with demand increasing because of factors like population growth, increasing complexity around the long-term conditions that people are living with, the impact of new treatments and technological innovations. So referring is a really important and significant core part of what general practice does. With the pressure that primary care is under, anything that we can do that reduces the amount of downstream work subsequent to the generation of a referral decision is something that will have an enormous impact on the day-to-day working of general practice. From a patient's perspective, it can't be right that there is something like a 5 or 6-fold variation between doctors in making a referral decision. So for me as a patient, it can't be right that one doctor is 6 times more likely to refer me to see a specialist than another doctor is. And it's that unexplained variation that we need to be able to explore and address. I think there's enormous potential around using machine learning technologies and thinking to be able to automate large portions of the referral management process. So my expectation is that the new technologies that we introduce should free up clinician time to be able to have more meaningful conversations with people. Putting it simply, it's allowing us to deliver better health outcomes at lower cost.
So there's 2 key points there. One of them is demand is increasing. And the other is that we really need to get consistency in care provision. And this is a really big issue in the United Kingdom. So just to come back to the referral management challenge. So patients need to know that they're going to get the same treatment regardless of who they see. It's not right that you can go to a general practitioner with a sore knee and then go to another one with the exact same condition and have one refer you to a physio and the other one refer you to an orthopedic surgeon. And also, government needs to be confident that the care is being provided for the most cost-effective way. And it's only when this happens and this visibility is known that they'll start working on introducing new services, because they'll have that confidence, and also they'll be able to manage demand. So there needs to be a solution in place where they can have this visibility. So we'll talk a little bit how we meet this challenge. So at psHealth, we've developed ART, or Advanced Referral and Triage. So ART is built on Appian. It's a multi-tenanted solution, and it aims to get the patient to the right place the first time. So it does this through a combination of automation, workflow, and exception management. So, and automation and workflow handle a majority of the use cases and referrals. So just to talk a little bit about how ART works. So a general practitioner sends all of their referrals to a virtual single point of access, and they can do that email, fax, however they need to. So ART will receive the referrals, and it will look to identify the primary referral letter. So it does this through optical character recognition, natural language processing, and pattern recognition. So then ART will identify what patient this referral is all about. So it does this for looking for names, it looks for dates of birth and unique patient reference numbers, such as the National Health Services, they have an NHS number. Once it's done this, what it will do is it will then say, what's the primary reason that this referral is being sent? So what we're doing is looking for a general primary reason and a specialty that this is being sent. And we also look for a priority. So this is really important for us because we have service level agreements that can be applied. So for instance, a cancer referral needs to be actioned a lot quicker than maybe just a routine sore knee. So once we've extracted all of this high level information, what we do is we run this through our triage engine. So the triage engine takes in this high level information and the referral text from the letter. And what it does is has any supporting documents such as blood tests, and it can apply specific workflow rules. So for example, you could have any routine referral that has knee pain for a patient between the ages of 20 and 30, and it can be sent straight through to a particular community service. So you might have a low-cost community service, and you say rather than sending it to that orthopedic surgeon, it'll automatically go there. So there's some really large cost savings to happen. And vice versa, if a referral letter comes through and mentions anything to do with a lump or it could be possible cancer, then a task is generated for review. So if a referral needs to be clinically triaged, a task is created. And once that's created, it'll be reviewed and be moved to the pathway outcome. So what this means is that there could be a booking happen, or they might have to contact the patient or go back to the GP. And what I'm going to show you today is how we've integrated Appian's AI service into our triage decision or clinical triage, and we're going to show a service recommendation. So we're going to show along with an indication of cost as well. And what this is doing is really improving the data points available to someone who's doing clinical triage to determine where is the best place for a referral to be sent. So before I show this, I just want to talk a little bit about our referral letter corpus. So we've processed over 500,000 referrals through this product. So we de-identified these for the presentation today, but we've used the data to train a model. So these referral letters cover around 90 specialties. They cover musculoskeletal, general dentistry, and there's a whole lot of others. One of the challenges that we've had with this product is that we have a really large variety of forms. So some can be identical, some can have really minor differences across specialties, and we've had the challenge of being able to say, well, how can we find this sort of consistent information and be able to put these into the right groups? So what ART does is that, we either get the forms come in a little structured, or that we will structure it ourselves and we sort of work up the referral. And again, we use optical character recognition to do this. And we found that we've been able to identify very successfully, what specialty a referral is, what is the primary reason, what is the priority. And in the rare case that we can't, it's easy. We just can throw a task in Appian and we can get someone to look at that. So where does machine learning fit? So we've been really sort of excited at psHealth that we've been able to implement a product that's been able to collect all of these referrals. We haven't had to have a massive amount of change management in place. And we've been able to provide some consistency in care provision and offer some really, really big returns. Machine learning's really powerful, and that, as Jorge mentioned earlier, it can identify patterns without someone having to hard code these in. So at the moment within ART, previously we've had thousands of rules that have said, this referral must go here, this must go there under these conditions. Now these require a lot of upkeep. We have whole teams of people that their sole job is just to make sure these rules are correct. And what Appian are offering here is the potential to reduce these rules by massive factors or even do away with them completely. So savings are obvious, there's no more upkeep. So now that I've hopefully given you all a bit of background, I'll give you a bit of a demonstration of the recommendation engine. So first, just to cover the main task. So this task is generated whenever there's an exception. So as I mentioned earlier, we have our triage engine, and what it aims to do is cover around 70% of all workflow and have that move through automatically. But where we've found that there's these things that don't fit into what we can predict, we can throw a task and a clinical triager reviews it, and then they make a decision. On the left-hand side, we show the referral letter. You can download these to look at all the documents that are attached. And on the right-hand side, what happens is that we've worked it up and we sort of have set these into the queues and the teams that they need to review it, and we've put the service recommendation, which I've encircled here, and I'll talk about this a bit more. Okay. So this is a little graphic that will go moving. So we have the confirmed triage outcome section. So this is presented to the clinical triager when ART's identified that there's a particular referral that needs to be reviewed. So it could be triggered for any reason, with keywords met, keywords not. So this particular referral is a specialty of physiotherapy, as you can see at the top. The primary reason is lumbar or lower spine pain. You'll see that the priority of this is routine, and the triage decision has been automatically set to community care. So what you'll see is this is where the integration occurs, is in the service recommendation section. So the machine learning model that's been trained has recommended that there's Jorge Healthcare. It's done this based on previous referrals for patients with similar demographics, similar conditions, and we've been able to throw up a list of the top 5 specialties with a percentage there. So we've also provided an indication of costs. Now we do this using publicly available tariff information. Now this is really important as well, because we really do believe that costs should always be considered when it comes to providing good healthcare. If we need to update the reason, we can do that too. So we can change this reason. We'll come through here just in a moment, and we can change that reason to I think I go up here and we change that up to hip pain. And you'll see here that we change this to hip pain. And what that does is then that goes back, hits the AWS, the web API call, and it will bring the new recommendation, and you'll see here that it updates. So it's really easy. This didn't take us long to implement. It's quite simple to do, but it's really, really powerful to be able to provide clinical triage with this information. So once they finish doing this, what they do is they would finally review. They decide that we're going to send this to New Haven Polyclinic. We have an 81% likelihood that this is the correct service. They can go through. They can add triage notes, which are kept against the case. And once they've done that, they just confirm that it's appropriate, and then they would submit this referral. So yeah, this is really powerful. We've got a referral letter, we've made an assessment, and we've also been able to have a recommendation, and we've been able to choose this, and it's based off all of these other referrals that we have in the system. So this does come with some considerations. So first, I'd be remiss if I didn't talk a little bit about clinical governance. So it's really important when we worked on these screens, that these are recommendations. So, you have to be sure that when you are showing this with machine learning, that you are saying you are making a decision here. This is a suggestion. And we believe we've done that, in this case. But these are always things that you need to think about. We've also identified that you need to randomly flag some referrals, and you can bring that back through for clinical triage. Now, what this does is it just ensures that there's evidence that all referrals are being consistently triaged, that it's happening. And this is just good governance stuff that you should build into your product. Bias. So bias is really important to watch out for. So with any recommendation engine, if everyone is just blindly selecting, the top selection without actually, having their input there, you're going to introduce some bias over time. So the idea is obviously that you still have that expert system in place, which is a person when you're throwing these tasks and you're saying, you make a decision. So also we have sample size. So again, we had 500,000 referrals for this. So we had for some specialties really good coverage, but we did find that if you don't have sufficient data for the model, as Jorge mentioned, if you put crap in, you're going to get crap out. So, you need to just be sure that if you don't have a sufficient number of samples, that you may not want to show a recommendation engine. So these are all things that you just need to consider. So my main point here is that you need to understand your data. We at psHealth, we have a data scientist, and they're working on how we increase the accuracy of the recommendations. Look, this can be achieved by a couple of things that come to mind. You can add additional features. You may want to separate this by specialty as well. So rather than having one model that's trying to generalize for everything, you create special models for every single specialty, and then you use that so you get better accuracy. And you could also reduce the number of features, and you could try to generalize more. So machine learning, if you try to put too many features in, sometimes what you'll get, it'll overfit, and it will just say, I only know it under one of those particular use cases. So you've got to think about this as well. Next, our roadmap. So, in terms of where we see this going, we don't want to provide just recommendations based off patient demographics and what's happened previously. What we really want to do is we want to be able to say, how do we get outcomes from health? So not only what have been previous referrals, but for patients who went for treatment, are they happier? Did they say that they had good care? How do we integrate that into our model? And from that also, how do we integrate capacity, and how do we integrate demand? So if we do all of this, what that means is that you can reduce some of that bias. And also, we can make sure that patients are being seen the earliest. They're being seen at the most cost-efficient place. So there's a lot more that you can do with this. This really is just the beginning. And look, lastly, our ambition. So at psHealth, we believe that 70% of these referrals can be processed either by machine learning or by rules. And then the remainder, the 30%, is that we use this through exception management. So, ART doesn't have just applications for referral management. There's some big ones like health insurance, and our triage engine can also be used in a lot of other case management solutions or applications. So with a combination of what we've done with psHealth and our experience, with Appian's power and the integration here with machine learning, we really are helping our clients deliver more efficiently at a lower cost. Thank you, everyone. Have a good afternoon.
Thank you very much. That was something, huh? I mean, it's just one of the use cases, and every time the more I think about it, the more use cases come to mind. We at Appian, for example, have always been very proud of the customer satisfaction that we have whenever we do those surveys. But for that remainder 3%, we can apply a combination of AI technologies to make sure that we're proactively figuring out what we can do better. So that kind of leads me to the other quick demonstration I wanted to do for you guys, which is around, let me open this up, around natural language processing and image recognition. So I mentioned earlier that natural language processing can be used in a lot of ways to kind of take that unstructured data and apply some structure into it. Now, you can actually use a machine learning model to create a natural language processing, right? What that means is you feed it thousands or millions of phrases in one column, and the other column will have a grade. This is good, this is bad. And that's very important, for example, in medical conditions. You want to know that it just so happens that if you mention a potential diagnosis with the word positive, that's actually bad, right? If you're test positive for something, but if you test negative for something else, that's actually good. But there's also the providers out there, or the models that are already built, such as, for example, Google's natural language processing. Now imagine all the millions, if not billions of dollars that companies like Google have invested every time you make a search, right? And you have, I want, search for hot dog images, right? And you get pictures of puppies that are in a hot day, and like, no, then you search again, and finally you get a picture of an actual hot dog, and then that interaction is recorded and logged, and they've made it so that it's better and better and better. You make a phone call. So there's a lot of value that goes to a pre-made model like this one, and this is just showing a connector and different ways that you can use that, right? So the way it works is you have a score from -1 to +1, and these basically tell you how the sentiment is. Is it bad? Is it neutral? Is it positive? And the magnitude just tells you how much emotion is there, regardless of whether it goes on one side or the other. How emotive is a comment? So here you can do things like, hey, you have some pre-made phrases here, like I am very happy. It has a 0.8 score with 0.8 magnitude, and you can do things like, oh, yeah, I hate cilantro, right? And that's like -0.8. But there's other interesting use cases. Let's see what happens when we put this to the test with some famous speeches, like Abraham Lincoln's The Gettysburg Address, right? So you can see the whole speech here, but look at what's happening here on the right side. It automatically identified some of the key themes, right? You can do not just overall analysis, but you can do entity and syntactic analysis. You can find out what is the most positive and the most negative. So the example I was talking about, customer feedback, imagine putting this to the test into the comments that you get back, right? What are the people that love us, what are they saying the most? And the people that don't like us as much, why? Right? And you can automate. You don't have to have people reading through all of them. You can get the summary like that. And of course, you can say that this makes it possible for you to make a search that says, give me all the positive reviews from customers in Australia, right? Even though customer was not there, it can identify the key themes and the key aspects of it. So it's really, really interesting. And then you go into image analysis. Now this, granted, works very well with things that are very well known, but it's getting there as far as you saw what happened with Matt Culkin's picture, right? You can identify it's a face that is happy, but it's still some of the stuff, like it might not recognize that, oh, that actually happens to be Matt Culkin's. When it does, I'm going to be a little bit scared, but we'll see. But let's just show you like what happens when I feed some like famous landmark images, right? So I'm actually, when I click on this link, it's actually going to make a real-time call to the service and try to identify what it is. And when I click on show results, I myself was impressed, right? In this case, it identified this is a Golden Gate Bridge. It's in San Francisco, California. It's a bridge. It's a landmark. It's a reflection. It's a suspension. It's actually located right here, right? The same is true if I feed it some images, right? It happens to be the Starry Night by Van Gogh, and I mean, it's incredible. And you can upload your own pictures, and if you want to play around with this or with the model that I showed earlier, I would invite you to go to the the registration desk, we have a desk there for the talk where you can play around with the decision designer, as well as all the AI features. And it's located right there. I think I have a map. Yeah, this is the Appian Pavilion. So it's right there next to the registration areas, and I think on the first floor down on the street level. And we have a couple of minutes, so I want to open it up for questions from the audience. Just note that I'll have somebody go and give you a mic so we can record it for the session. So yes, right here. The gentleman in white, if you don't mind waiting for the mic. There you go. Thank you.
So the question is, do we have to have a separate account with Amazon to use their AI capabilities?
Yes. So using Appian's secure credential store, you'll be able to add your credentials or your system, whether you want to do it by system or user, and then you'll be able to leverage that. The same is true whether we are using Google's image recognition and things like that. You'll leverage those services. Thanks. Any other? Yes, right here in the front. Gentleman with the brown jacket.
Yeah, okay. So in the default model you showed when you read the Excel file and had a result, and then there was no bias for any particular column, right? But whereas there might be a different correlation,
yes,
right? One positive, one negative. How was that actually fed in, or
well,
how was it factored in?
It's an excellent question. Before actually feeding the data to the model, we do a correlation analysis, and it's part of the data source and the data model that it creates. So it does that. It figures out what columns have the most relevance, and more importantly, which might not have as big a relevance, right? So that's part of the advanced configuration options that you can do, but also it does part of that statistical analysis automatically. Yeah, it's part of the when I was talking about blissfully unaware, that's what I mean, right? A lot of that stuff is happening behind the scenes. Any other questions? Yes, the gentleman.
I'm good. I don't need a microphone. So when you guys do the analysis, and is that data stored anywhere? Is it forgotten and you just keep the algorithm? What happens to the data you feed into the analysis engine?
Great question. So all of the data, when excuse me, when the statistical analysis is done, all of it is stored depending on which service provider, right? Microsoft works a little different, Google works a little different, but they can all follow a similar pattern. But all of the data is stored at that location. That's why it's important to do it under your account, right? But yes, all of that data, all the statistical analysis, all of that is stored at the service provider's in the service provider's cloud. The one thing that we do is the data model. So inferring the data types and all of that stays, it's not actually stored anywhere, it's just passed kind of as a parameter to the model.
So as a follow-up, the psHealth application that you did, when they fed that in, those diagnosis codes and all those kinds of things, that PHI, there was no security concerns around having that data stored at the site?
There's always security concerns, right? There's the PII information and things like that you want to make sure that if it's not necessary, you don't use it. At the same time, for example, AWS is the platform that we use for as our cloud provider. And the certifications that you see and the level of security there is pretty high, right? So I'm not going to sit here and say, oh yeah, don't worry about it. Upload your credit card information, and let's be careful, right? It's sensitive information. It's going to be in a secure, well-protected environment with security certifications and everything. But there's always considerations about what type of data you're uploading. And I think we're out of time for any more questions, but I'll be happy if you just look us up, and we'll be happy to answer questions. And the same goes for the Appian Pavilion booth. Thank you very much for joining us today.